Hello teacher and hello everyone. And now I will introduce my deep learning project. It's a midterm project topic. It's image recognition on empty datasets. And to the table of the content. The first one is what's the deep learning. The second one is the image classification project. And the third is result of my project. And the last one is conclusion about my project. So let's dig into what is learning. Deep learning is a subset of machine learning, essentially a neural network with three or more layers. These neural networks attempt to simulate the behavior of the human brain. So apart from the matching, its abilities allow it to learn from large amounts of data. While a neural network with a single layer can still make approximately predictions, additional hidden layers can help to optimize and refine for accuracy. Let's talk about the neural network. Neural network is also known as the artificial neural networks for or simulated neural network and a subset of machine learning. It's also deep learning uh, and are at the heart of deep learning algorithms. The name and the structure are inspired by the human brain, the mimicking for mimicking how biological neural signals to one another. You see in the picture is a deep neural network which have input layers and the multiple hidden layers and the output layer. You see the cycle is a neuron and we have a multi-neuron on hidden or each hidden layer and some multi-neurons which connect to either neuron together and the output is the subset of neuron. The second type of deep learning algorithm is the convolutional neural network. Convolutional neural network is a type of deep learning model for pre-processing data that have a grid pattern such as image, which is inspired by the organizations of animal visual cortex are designed to automatically and adaptively learn spatial hierarchies, of the feature for low to high level pattern. It simply we understand the C and N like the automatically feature extraction. As you can see here, we have third picture map in the left hand side. So it's a multiple or no, conversion with the filter or uh, kernel third x third and the output volume with feature map. Is as you can see in the picture is the convolutional neural network architect. A simple neural network architect is composed of the convolutional layer, the map pooling layer, and the fully connected layer. In the first one, we have an image input with the shape 34x 48x, and we convolutional in the input and map pooling with that with downsample the feature map And the last one is a fully connected, which we have to flatten the feature before map pooling, and we use the fully analyze dance or like neural networks to classify the objects are in the input, classify which object we want. So the next types of the deep learning model is a recurrent neural network. Recurrent neural network is an artificial neural network that uses the sequence or the time series data. These deep learning algorithms are commonly used for original or temporal problems such as language translation, natural language processing, speech recognition, and image caption. They are incorporated into popular applications such as Siri, voice research, and Google Translate. The type are named is a one-to-one, one-to-many, many-to-one, and many-to-many. You can see in the picture. So next topic we content we will introduce is the image classification my project. So I image in, we have to know that image classification is a predecessor of object recognition is a critical step in the entire process used to predict the categories of any given image. For example, if you have a picture in here of the cat or dog, it's part as the image recognition system will analyze dogs or cats score feature, face size, limbs, attendance, X, and then it's compared to the thousand trained images to display the dog or desk as an cat or an apple. In the picture here, uh, this is the simple model CNN. It may be not CNN. This is simple neural network. It classify the cast image. The cast image will spread it like the pattern or grid pattern as it use the conversion, and so it will be flattened and put into neural network architect, and the neural architect will process and given output and give output or the output is cat or is not cat or dog. So in my project I use the dataset. The datasets I use the MD's database. It's an large collection handwritten. It has a training set of 60,000 examples. In the test set is 10,000 examples. Image size is a one channel. Width and height is a 28. The picture which will show the 10 class from 0 to 9. It's a handwritten uh, picture, handwritten disease picture. So I format the training process with two strategies. Strategy 1, the training is 60,000 sample and the validation is 10,000 sample. And strategy 2, its training is 50,000 sample and validation is 10,000 sample and testing is 1,000 sample. The distributed that is quite balanced. Uh, it's very good for training. And next is how I implement in my neural network. I use a simple neural network to train and lead data sets. Until in stage 1, I divide into the two sets, training and validation, and then put into a training model include two hidden layer 32 and the output layer is 10. With 10 epochs, learning rate is equal to 0.1 as I saw below in here. And I also use a minibus size 200 the training. You can see in the some next picture. I use the conventional. I use the neural network to process and classify the image handwritten sick. So I read around. I guess uh, I'm uh, I'm I'm gotten in model is you can see in the accuracy and loss. Fingerprint accuracy is quite good. It seems like the overfitting when we train more, and the loss curve is small. The values is very small and generative in the last epoch. In comparison coefficient metric, the coefficient metric show that the the classification is very good. It's small error with the last number of training, so it's very small. Conclusion. From the result of the training, I felt that applies the neural network to the image recognition problem, they give more impressive results than the basic machine learning algorithm. However, it still has many limitations. Its large number of parameters and a long training process. I aim to use CNN to train images that get good feature and reduce the improved parameter. Thank you for watching. Thank you for hearing me. I'm sorry about my voice and maybe I'm sick. So the last one, thank you for hearing my presentation.